this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today in part 4 of properties of inverse trigonometric functions, we will be proving 3 more properties. But before proving them, let's review 2 of these trigonometric properties which will be used in proving today's properties. And these properties are cos pi by 2 minus x is equal to sin x and sin pi by 2 minus x is equal to cos x. So to prove first property, apply cos x minus y, and as we know that cos x minus y is cos x cos y plus sin x sin y. So we just need to replace x with pi by 2 and y with x to get cos pi by 2 minus x. So cos pi by 2 minus x will be cos pi by 2 cos x plus sin pi by 2 sin x. Now cos pi by 2 is 0. So 0 times cos x plus sin pi by 2 is 1. So 1 times sin x. So we will get sin x. Therefore, cos pi by 2 minus x is equal to sin x. Now, similarly, for second property, we will be using sin x minus y, which is sin x cos y minus sin y cos x. Now replace x with pi by 2 and y with x to get sin pi by 2 minus x. So sin pi by 2 minus x will be sin pi by 2 cos x minus sin x cos pi by 2, and sin pi by 2 is 1, so 1 times cos x minus sin x cos pi by 2 is 0, so sin x times 0. So we will get cos x. Therefore, sin pi by 2 minus x is equal to cos x. So we will be using these 2 properties in proving our today's properties. So our first property is sin inverse x plus cos inverse x is equal to pi by 2. So to prove this, let sin inverse x is equal to y, or y is equal to sin inverse x. Now take sine both sides, then sin inverse x will be x. So sin y is equals to x. Now since sin x is cos pi by 2 minus x, then sin y will be cos pi by 2 minus y is equals to x. Now take cos inverse both sides, then cos inverse cos pi by 2 minus y will be pi by 2 minus y, because cos inverse cos theta is theta. Now substitute the value of y, which is sin inverse x, then pi by 2 minus sin inverse x is equals to cos inverse x, or sin inverse x plus cos inverse x is equal to pi by 2. So this is how we prove our first property. Now our second property is tan inverse x plus cot inverse x is equal to pi by 2. Now to prove this, let tan inverse x is equals to y, or y is equals to tan inverse x. Now take tan both sides, then tan inverse x is x, so tan y is equals to x. Now tan x is sin x over cos x, and sin x is cos pi by 2 minus x, and cos x is sin pi by 2 minus x. So cos pi by 2 minus x over sin pi by 2 minus x, which is cot pi by 2 minus x. So tan x is equal to cot pi by 2 minus x. So similarly, tan y will be cot pi by 2 minus y. So cot pi by 2 minus y is equals to x. Now take cot inverse both sides. Then cot inverse cot pi by 2 minus y will be pi by 2 minus y, because cot inverse cot theta is equals to theta. Then pi by 2 minus y is equals to cot inverse x. Now substitute the value of y, which is tan inverse x. So pi by 2 minus tan inverse x is equals to cot inverse x, or tan inverse x plus cot inverse x is equals to pi by 2. So this is our second property. Now our third property is cosec inverse x plus sec inverse x is equals to pi by 2. Now to prove this, let cosec inverse x is equals to y, or y is equals to cosec inverse x. Now take cosec both sides. Then cosec inverse x will be x, because cosec inverse theta is theta. So cosec y is equals to x. Now cosec x is equals to 1 over sine x, and sine x is cos pi by 2 minus x. So 1 over cos pi by 2 minus x, which is sec pi by 2 minus x. So cosec x is equals to sec pi by 2 minus x. Similarly, cosec y will be sec pi by 2 minus y. So sec pi by 2 minus y is equals to x. Now take sec inverse both sides. So sec inverse sec pi by 2 minus y will be pi by 2 minus y, because sec inverse sec theta is theta. So pi by 2 minus y is equals to sec inverse x. Now substitute the value of y here, and the y is cosec inverse x. So pi by 2 minus cosec inverse x is equals to sec inverse x, or cosec inverse x plus sec inverse x is equals to pi by 2. So this is how we prove this property. So far we have proved these properties of inverse trigonometric functions in a part 1, part 2, part 3 and part 4.